Welcome back, friends. In this question, we wanted to find the load in member CH. In this member, we wanted to find the load, and we wanted to apply the method of joints in this question. So first of all, I wanted to find the slope of all the angle members. So this value, if this total is 20, I can call this is the half. So this value is 10. The horizontal, I'm gonna erase it. I'm gonna rewrite it. So the horizontal component is 10, and the vertical component, I can take it from here. This value is given to me 20, and this value will be 17.3. And same will apply to all these members. So this vertical component is 17.3, and this is 10, this is 20, and same will apply here, same will apply here, same will apply here. Now, because we wanted to find the load in member CH in this member, that's what we wanted to find. So we are tempted to draw a diagram about point C. In method of joints, we always try and draw the point diagram. So in this, we will select the point C. So if I draw the diagram about point C, I will come up with a diagram like this. And then if I write down the equation in the vertical direction and the horizontal direction, so this is the horizontal direction equation. The equation will look something like this, and if I write the equation in the vertical direction, the equation will look something like this. I can't solve these values because I don't know what is the value of CB, I don't know the value of CH, neither I know the value of CD and CG. And same case, I don't know any value here, I don't know any value here, so I can't solve this equation. I'm gonna get stuck. So in these questions, what we need to do, if we can't solve these equations about one point, so we need to go back to the complete body diagram. So what do I mean by complete body diagram? It means we wanted to find the reaction loads. So we need to start with the finding reaction loads. So in complete body diagram, this is the commitment we've made that when we are drawing the complete body diagram, we will draw only the reaction loads. So reaction will occur at this point because these are the fixed points. We will draw the reaction load at the fixed points, at this point and this point. And because this is a pin joint, so there will be a horizontal load also, like this. So, and then we will only show the external load. So external load in this case is 15 kips and 6 kips. So that's what I've shown in this diagram. And then I will write down the equations in horizontal direction and vertical direction. In horizontal direction, RAX value is 0 because there is no other horizontal load acting in this reaction. So that's pretty easy to find. And then I will write down the equation about sigma f of y equal to 0. And then so vertical loads, so this is vertically upward, this is vertically upward, and this is downwards. 15 kilopascal is acting in the downward direction. This is also acting in the downward direction. So that's what I've written. Anything up is positive, anything down is negative. So I figured out one of the equation. Then I still can't solve it because I don't know the value of RAY and REY. So then I will write down the moment equation. So I will take the moment about point E. Oops, sorry. What happened? Let me fix this. So I'll take the moment about point E equal to 0. So now if I take the moment about point E equal to 0, and then I will write down the equation about this point, and this force, this 15 kilopascal is trying to rotate in counterclockwise, 6 is also trying to rotate in counterclockwise, A is trying to rotate this body about point E in clockwise direction. Anything in clockwise direction, we've considered it as negative. Anything counterclockwise is positive. So we've written down this equation. So we will come up with this equation. So this is the force, this is the perpendicular distance 50, this is the force, again 15 kips times load, shall I say, this is the load, and then this is the perpendicular distance. And RAX, because there is no perpendicular distance from point E, so I've considered it 0. So then I will, from here I will be able to find RAX value. RAX value comes out to be 12.5 kilopascal. And then if I put this value back in this equation, I will be able to find REY also, which is 8.5. So now once we figured out these values, I'm making a short video because this question is very lengthy, and I think it'll take me more than 20 minutes to complete this question if I'm doing a live presentation. So then I figured out RAY component, which is 12.5, and now I will draw the diagram about point A. So if I draw the diagram about point A, let's go back in here. If I draw the diagram about point A, about this point, this will move upward direction. I don't need to represent any RAX because it is 0, and this is upward. This will be in this direction like this. So that's what I've drawn here. So I will write down the equation sigma f of x equal to 0. So horizontal, anything towards the right of point A will be considered positive, anything towards the left will be considered negative, and same way anything up is positive, anything down is negative. So I will write down the equation sigma f of x equal to 0, and I'll come up with this equation, and then sigma f of y, and then I will come up with this equation. Because 12.5 is acting upwards, and then AB, this is acting at a slope, so I have to take the vertical component AB. 17.3 divided by 20 equal to 0. From here I figured out the AB value, and once I figured out the AB value, I'll put that value back in the sigma f of x in this equation, AB value back in here. So I need to change the color. So I will put this value back in here, and that's gonna give me AH value, and AH value comes out to be 7.23. So once I figured out the value of AH, then I'm gonna move further. I will draw a free body diagram about point H. So now if I draw a free body diagram about point H, again sigma f of x, I will write down the sigma f of x equal to 0. Anything towards the left hand side is negative, AH negative, HG positive because acting towards the right, BH is negative and taking its slope, and then in this case again this is positive. And then sigma f of y, we will write down the equation for sigma f of y. This will be BH times this is the vertical component, and then this is 17.3 this, and we will write down these equations. So I can't solve these equations because I know the value, or I know the value of AH here. I know the value of AH, but I don't know this value, I don't know this value. I'm stuck here. So what I'm gonna do, neither I know this value, neither I know this value. What I'm gonna do, I'm gonna try and draw the free body diagram about point B now. So let's look into free body diagram about point B. So this is your diagram will look like, oops, sorry, my computer is really slow. So this diagram will look like this. So because at point P, if you're gonna go back into the previous work, you'll see that there is a load acting in the downward direction about point B also. So we have to consider that value of 6 kips. So this is the diagram you will come across, and then you will write down the equation in x direction. Sigma f of x equal to 0, sigma f of y equal to 0. Same way the way we've written the previous equations, you will write these equations, and once you've written down this equation, from here you know the value of AB value we've already figured out, that is 14.45, and that was a negative value. So this is really important. So if it was a negative, I've considered the negative sign, I've kept the negative sign here. So now from here, by solving this mathematical equation, I was able to find out the value of BH. So BH came out to be 7.5. So now I figured out the BH value. I'm gonna go back into the question where I was doing. Sorry, it's gonna take a couple of seconds to load up that slide. So just meanwhile, if you can stop, if you want to pause the video, and you can you have the BH value, you're gonna put this values back in the previous equation. you will be able to find the answer to the question. So let's see, hopefully it appears up. Oh yeah, thank God. So now I'm gonna go here and gonna go here. So I know the value of BH, which we found out from the previous slide, and BH value I'm gonna file it here, and then I wanted to find the CH value. So in this equation I'm gonna file the value of BH, and that's gonna give me the value of CH. It comes out to be negative, so that's why I've written down this as a compressive, and that's what we wanted to find. This is my answer. So hopefully you were able to understand. So have a good day. I'll see you soon. Bye.